Hey Lonnie, I wanted to show you a video rather than try to explain something over email. I thought I'd show you a video of what I'm talking about with the Sidereal Tech tracking. So I'm going to change to the screen now, I think. Okay. So here is, come on, I need to change, you didn't take it, there we go. Here is the path a star takes as the Earth turns. So here's the North Celestial Pole. So looking in the sky from the North Celestial Pole, this is east with respect to the sky, not with respect to the pole. Everything is south of the pole. But right here, it lays up, that's 37.5 degrees north, above the north line. So here's true north. 37.5 degrees up is the Polaris area here. Now, but come over here. That star is going that way. 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 Another way to look at it is if this is north right there, then guys over in the east are rising, then they transit, then they're setting, and then they're anti-transiting. Now if I come way the heck further over here, I will get to that celestial equator, and they're basically doing that. And then the stars on this end are going around the sky like that. The stars on this end are going around in the sky like that. Okay, so right there, that's what the stars are doing. Now, these guys, this is east. These guys are going up and to the right. Then when they get towards the south, they're just going to the right. And when they get to the west, they're going down and to the right. But what I want to talk about is a star in the east. Now, if I go from the pole straight over and I pick a star on this line, they are all going straight up, because below that line, you're going up and to the right, and above the line, you're going up and to the left. But as they cross that line, they're going straight up because their path is normal to any radial coming out of the pole. So we have a right angle right there. We got one here, but my picture sucks. Anyway, if I were to point my telescope due east at the same altitude as Polaris, the star will be moving straight up. I'm not talking southeast. I'm not talking northeast. Over here, the same thing, but the problem is this line as projects in the sky curves down. So if we were to go straight east, the same altitude as Polaris, the star is going straight up. So when the Sidereal Tech drive is driving, only the altitude motor is turning. Right here, the azimuth motor is cranking to the right real slow. It comes to a stop and it starts cranking to the left real slow. Over here, the azimuth motor is cranking and the altitude motor is stopped. Same down here. So, what I could do is point the telescope 37.5 degrees high due east and do a 10-minute track on that star with a graduated reticle whose divisions I know, and after 10 minutes determine how far that star has traveled in arc seconds. Once I've done that, let's pretend it's fast by 25 arc seconds in 10 minutes. Like could figure out how many arc seconds that would be in 23 hours, 56 minutes, and 4.1 seconds, which is a sidereal day. Divide that by 23 hours, 56 minutes, 4.1 seconds, and I'll get something like 1.000 number, which is the overcorrection speed. Or if it was slow, it would be an undercorrection speed, 0.99 something. So I could multiply the tick count in my Sidereal Tech altitude controller by the reciprocal of that number, and it ought to bring it back to normal. Okay, so when I look at a star in the south, there's its path. Here's south. Okay, at least make it look like it's in the south. Here's southeast, here's south, here's southwest. The altitude motor is not running when the star transits the prime meridian. So if I were to go to a star on or very close to the equator as it transits, I could do the exact same thing. I could put a reticle on there, determine if it's too fast or too slow and by how many seconds in a 10-minute period, and then multiply the number I have set for my azimuth tick counter by the reciprocal of that number, and it should bring it back home. So I do it in the east and I do it in the south. Then I go in the house and I plug the controller into the computer and I adjust those numbers. I go back out and I do it again. Only this time it ought to be really good, but there might still be an error, so I do it again. I go in and reprogram the box. I come back out. It ought to be so good now that 10 minutes isn't long enough to play the game, so maybe this time I do it for half an hour, maybe 15 minutes before and 15 minutes after it hits that horizontal line, then 15 minutes before and 15 minutes after it hits that transiting the prime meridian. And I got a really good fix that time, come in and reprogram. After the third time, it ought to be right on the nut. Now, I don't know if this is how they do it or not. I hope this makes sense, and I hope you agree that this is a good way to do it. All right, thanks. See you next week. I don't know how to stop this thing.